2, 1, 0.
Right, stop. Now, something just amazingly awesome has happened right at this point. But before we get into that, let's look at a little montage of the day.
So we're here at flying field, and we tried to fly the F-15 on my rocket today, and unfortunately there was a catastrophic explosion up at about 50 meters. The rocket made it just fine with the parachute, but the motor blew out the front of the rocket. So basically the flight computer got a little bit messed up. We lost all the data. It's probably on the flash card, but we'll basically see what we can pull off the flash. The computer doesn't really work anymore, and there's something rattling on the inside that I don't know what it is. But it was pretty cool. The explosion was pretty cool. We went up pretty high, and I'd say this is a good day. What's happening next is this rocket's going to be decommissioned because it's really hard to repair and take apart. And the next one's going to be a special sort of carbon fiber frame design that I'm working on right now. And we'll see what we can salvage from this and put it in the new one and fly again pretty soon. 2, 1, 0.
Alright, so this is the defining moment of the rocket launch. You can see here the rocket is angled at about 25 maybe degrees, and it's continuously straying off course. And as I scroll through frame by frame, you'll see the parachute actually deploy right about here. So the parachute is deployed because I have a limit on how much of an angle the rocket can go at. So the limit is 30 degrees. Once we hit 30 degrees, the rocket says, hey, that's too much for me, and I'm going to now just go into abort and launch the parachute to slow down. It's mostly a safety thing. So you can see here the parachute comes out and it starts to unravel, and all of a sudden, boom, we get an explosion. So this frame is good, you know, the motor is working well, and then all of a sudden, boom, there's an explosion right here where the motor is. And if I keep going further, it looks even worse. You can see here there's 2 pieces of debris that come off the rocket, and now there's 3 pieces here. And I think this piece up here is the actual rocket engine. So the actual engine got pushed out. Where is it? Yeah, the actual engine, I think right here, gets pushed out of the rocket, and the rocket, and basically it explodes. Luckily, the parachute still works and is still attached to the rocket, and it's able to bring the rocket down safely to the ground. The really cool thing about this, though, the really special thing, is that the parachute triggered right before the engine exploded. Now, if this is the opposite way around, if the engine exploded first before the parachute had a chance to trigger, then the rocket would have just fallen out of the sky. The parachute would not have triggered, because what happened when the motor exploded is it impacted the bottom of the flight computer and did something to basically turn it off. So the flight computer, right when the motor exploded, the flight computer just shut down. So the reason it's special is because the parachute was able to trigger right before that explosion. And that's such an awesome coincidence that that happened, and it happened just a split second earlier. And if I set the angle for the abort to be something like 40 degrees or 35 degrees, then the parachute ejection, the abort signal, probably wouldn't have happened in time, and the engine would have exploded and the thing would shut down and it wouldn't run the parachute. So here I have a really great photo showing exactly what happened a little bit after the explosion. It really tells a great story. So what you see here is the parachute obviously has engaged, and the rocket's coming down, or beginning to come down slowly. But there's also a few other objects here in the air with the rocket, and one of the most prominent ones is this one. Is this one right here. This is the F15 rocket motor that blew out the back of the rocket, basically. So the force is so great that this thing just blew out from the bottom. And we found this later in a field. But the other two pieces, or objects, are pieces of tape. So these are two pieces of green tape that were taped to the side of the rocket. And they're basically taped to the side of the rocket to prevent light from hitting the barometer, because for some reason the barometer is very sensitive to light, and that would mess up the barometer readings and give us the wrong altitude. But yeah, it's a really cool image, and really sort of shows exactly what happened. So here's just the aftermath of the TVC mount. You can see that whole top just blew off. That's a solid piece of plastic that just completely cracked and blew off and hit the flight computer. Lastly, here's just a little video of the aftermath of the flight computer. You can see lots of gross debris on it from the smoke and the black powder. Alright, so let's take a look at the data. So luckily for this flight I was able to get the data out of the flash chip, and you can see here the data really only goes up to about 3.45 seconds, because at this point right there is when the motor exploded and the flight computer was not saving any more data because it shut down. Luckily the flash chip was still intact and it held onto that data for us, and I was able to dump it onto an SD card. So right here you see a graph of just the state of the rocket. So the rocket goes through many different states throughout the flight, and one of the states here, the first one here, is the launch commanded state. So this is sort of this starts off when I press the launch button, and it runs all the way until it actually detects that the rocket has started moving upwards. So it actually takes about half a second for the rocket to go into the next state. The next state is called power descent, right? It's positive upwards power descent. This is when the rocket motor is firing and the rocket's going upwards, and it is basically flying under the engine power. After that, normally there's a bunch of other states, like you see 4, 5, 6, 7, 8. But what happened is the rocket motor, or the parachute, actually starts the abort sequence, or the flight computer starts the abort sequence. The parachute comes out, and when the abort sequence happens, that is state 9 over here. So we actually go from a power descent state, so when the motor is firing, and we skip all the other states and we go to state abort. And I'll show you exactly why. So we'll just move this graph a little bit, and let's look at the angles of the rocket, right? So we've got angles here of yaw and pitch. So the yaw of the rocket doesn't look too bad, right? So it goes up to about 17 degrees, and then it gets corrected for, but then it kind of overshoots a little bit, and it goes down to -6 here. So it has corrected it. There's a little bit of oscillation. And that's fine. And then here at this point where the abort signal happens, the parachute fires, and then, you know, the yaw does whatever it wants to do at that point. But this doesn't, this yaw has been pretty good. Like the angle of the yaw has been fine. But so let's take a look at the pitch actually. So if we look at the pitch axis right here, the pitch axis actually it gets corrected. You can see here it goes up and then it goes to 0, but then it goes downwards, and it's, you know, not getting corrected as much. The pitch sort of stops changing much here, but then it keeps going further. And you can see here as it keeps getting worse and worse, so the angle is getting worse and worse. Right about here, if I can actually do this, there we go. So right about here, you can see here the pitch angle is negative 30 degrees. So this is why the rocket went into an abort state, is because the pitch angle went past 30 degrees basically, or went to 30 degrees, and that triggered the abort. So it did what it was supposed to do. Now let's take a look at what the servo motor is doing. So the actual angle of the engine, or the motor, is dictated by the servos. So there's a servo for pitch. We have a servo Z. So if I overlay that on top, you can see sort of the servo is counteracting the pitch in the opposite direction, and then here it's trying to counteract the pitch, and here it sort of slows down. So the servo is kind of saying, okay, well, I don't have to push it that hard. But then as the pitch gets worse and worse, the servo sort of tries to react to it to help out. But the torque on the rocket at that point is too strong, and, you know, around this point, at the abort point, it doesn't do anything anymore. So yeah, so this is some cool data. Let's see how high we got. So we can see we have a barometer altitude here. So this shows the height. So it starts out at 0, and then through the launch it goes somewhere around here is when the actual parachute ejects. So there's a slight pressure decrease in the rocket inside where the barometer is, which reads as a higher altitude. And then right before explosion, we reach about 59 to 60 meters in altitude. So that was pretty good. If we look at, I also have a Kalman filter on here that tracks altitude, and this one actually tracks using the barometer and the accelerometer. So it sort of mixes those two sensors together, and we get a smoother graph. But the values aren't that much different between the two. But here you can see we go up to about 58 meters or so before the explosion. What else can we show? You can see the roll of the rocket. So we have the roll here, and the roll is fairly significant. So the rocket rolls a lot here. So this is probably what's causing the problem with the yaw, or with the pitch, is the rocket rolls and the servo is not able to react quick enough to that roll. And basically, you know, at this point, somewhere around here, this is where the parachute ejects, basically. So yeah, that was. Let's just look at also the acceleration. So we can look at the. Let's look at the raw acceleration magnitude. So this is really kind of just tracking the x. This is tracking x, y, z, and it's just the magnitude of all three. So sort of at this point, right there, at about 0.55 seconds, is when the actual rocket detects that there's some movement, and it spikes because the engine has a thrust spike, and then it sort of settles down at about 20 meters per second squared here. We can also look at the raw acceleration in the x direction, and this kind of tells you a different story, well, a slightly different story, where here you can see this really huge spike and noise is when the parachute got ejected. So this actually right here, the parachute ejects and it slows down the rocket, and that initial sort of burst, or that initial sort of deceleration causes these spikes here. We also have world AX, so this is just the acceleration in the world axis up and down. So it's basically the same as the X acceleration here. But yeah, so that's the data for this flight. There's a few more things like PID parameters and battery voltage, for example. But yeah, this looks to be all the data that we need, and yeah, next flight we'll have improvements